Okay, in your notes, we are on section 2.6. No, we'll do the quiz like in a half hour. That way when you're done, you can start on homework. All right, we're going to cover 2.6 and 2.7 again. The part that we're doing today is the proofs. We're going to take a look at what a proof is and what they look like. Your goal today is to get an idea of the sequence of thoughts, how you set up a proof to be a sequence, and what the three different types of proofs look like. Your assignment's mainly going to be having you take one form of a proof and turn it into another form. So seeing how the same information is there, it's just arranged in a different way. So the beginning of the notes would be on section 2.6. All right, I imagine you've told somebody prove it. I've kind of said that. So maybe a sibling, maybe a friend. But what do you mean when you tell them prove it?
To make it truthful, to show that they did something.
Do what?
To make it truthful and show that they did it, or show that something happened.
Show that something's happened and that be truthful.
The final word.
Yeah, what does it mean to prove it? Add some more? Who else had some? Yeah.
Show examples.
Show examples. How many examples?
As many as it needs to get right until I believe it.
So you believe it? Okay.
To make you feel right.
To make you feel right? How would you feel right? Give the truth to it? Okay. So could they just make up facts in what they're using to support their thinking?
No.
No, they have to be facts that you agree as true in addition to them being true. So you wouldn't just accept anything, it has to be like a certain law or rule or fact that's true. Okay, it's gotta be backed up. Okay, that's what we're gonna start doing here in geometry, is coming up with some support, backing up what we're saying, okay, in order to show that something is true. We're gonna try and go from a beginning to an end. Now, these are just some review things from mostly yesterday. Deductive reasoning is what we're focusing on, and that was the thinking process that uses logic. We did law of syllogism, law of detachment, law of contrapositive. We're drawing conclusions from given facts, definitions, and properties. It's not the inductive where we're looking at just a bunch of examples, but we're actually using rules and definitions, so more specific, true statements, I guess. And we're looking at what a proof is, an argument that uses logic, definitions, properties, and previously proven statements to show a conclusion is true. The theorem is the statement that we're trying to prove as true. So we're going to put together a sequence of ideas, and we're going to justify each along the way. These are some examples of what you can use to justify. Now, it's probably in your notes more in this kind of a look. See that on 2.6? Okay. This is more how it's in your notes. Okay, we're going to always begin with a hypothesis. Hypothesis is the given information. So you have to read the directions to every problem. It will tell you what facts you can use on this particular problem. The same diagram might have different information on another problem. So you need to pay attention to the specific given information. Then you can use definitions, postulates, properties, or theorems that we've studied so far to support your additional steps. And we're trying to reach the conclusion. The conclusion will be the statement that it says to prove. So we're trying to put a sequence of ideas together to let someone follow the thinking, and we're going to support each step along the way with a known fact. Now, what are some of the definitions we have done so far? Think back, chapter 1, chapter 2. What have we studied in geometry? What are some of the definitions? A theorem's not, a definition of a theorem. Okay.
Supplementary, complementary.
Definition of complementary angles and supplementary angles. Vertical angles. Think of anything from the first chapter that we did? Okay, we did polygons this chapter. I think from last chapter we did like midpoint. Yep, segment bisector, angle bisector. So this is the part that I can't do for you. You have to do thinking about, okay, what have we studied that I could draw upon? And if your mind is kind of blank, what could you do? Look at your notes. Chapter 1's packet, Chapter 2's packet. And in the back of the book, there's a page S82 that starts a list of all the theorems and postulates by chapter as we go through the book. It doesn't have the definitions in order. The definitions are just in the glossary. So you kind of have to know what we've talked about and what we haven't. Your notes might be the best place to look for that, okay? Because it's just not in order anywhere. Postulates. What are some postulates we've done? Good. Angle addition postulate. Segment addition postulate. I think those were the main two that we hit so far. There were postulates like 1, 2, 3, 4, 5 that talked about lines intersecting and that. Honestly, we don't really use those in proofs, but they were important ideas to get us started. Properties. What are some properties we've done? Just did them on Friday. They're on today's quiz.
Symmetric property.
Symmetric, reflexive, transitive,
Subtraction.
addition, subtraction, multiplication, division,
Subtract.
symmetric, substitution. Okay, and then yesterday we started some theorems, so we've got like a vertical angle theorem, congruent complements theorem, there were just a few different theorems. Okay? So those are the things that we can use to get from the given to what we're trying to prove. And along the way, there's usually a diagram. The diagram can supply you some information that's not written out. Like in the picture, if they have two lines crossing, I would know that there's vertical angles in that diagram, or maybe even that there's a linear pair in that diagram. So you can come up with things from the diagram sometimes, even if they're not stated. Okay, one form of proof is a two-column proof. In a two-column proof, here's a definition, fill in your blanks. In a two-column proof, you list the steps of the proof in the left-hand column. Those are like the math ideas. They'll go on the left side of our proof. And on the right side, you'll put the matching reason for each step. So the statements are on the left, the reasons are on the right. What kinds of things are reasons? The name of a postulate or definition or property, those things. Okay, here's an example. So you got some space to do a proof there. This is what it would start out like. It's giving us a couple things. So we're given that B is the midpoint of segment AC. And also segment AB is congruent to segment EF. And there's a picture there that shows you that A, B, and C are collinear. EF, that's not in the same line as the others. That's like the directions to the problem. That's what you're given and what you're trying to prove. Okay, now I'm going to show you the proof, and it's going to be in two columns. There's a left-hand side that has the statements. There's a right-hand side that has the reasons. Okay, we're going to try and see if we can follow the ideas and understand the difference between a statement and a reason. Okay, the statements, notice that those are some math facts. Okay, so the first statement says B is the midpoint of segment AC. And look what the reason is. The reason is that it was given. So write down number 1. B is the midpoint of segment AC given. Now before you really look at line 2, think about what's it mean if there's a midpoint? What's that definition?
Splits segment into equals.
I'm going to change one word for you to congruent segments. Okay? And so the next line is using what Clark just said, we've got a midpoint, so what can we come up with? Well, if B is the midpoint, then segment BA and segment BC would be congruent. That's what we're saying at this line. So line 2, segment AB is congruent to segment BC because we know the meaning, we know the definition of what a midpoint is. I put a 1 there to help you know, look back at line 1 and think about the definition. Okay, now line 3 says symmetric property. It probably should say of congruence. But what's symmetric property?
And then it says 5 equals x, and to switch it to x equals 5.
Okay, so you can take the two sides and switch them, like interchange them. So line 2 had AB congruent to BC, so line 3 is switching them. Segment BC is congruent to segment AB. Why? We have to kind of look at the rest of it to see why we had to switch that. Okay, next line brought in some more given information. Now 5 says transitive property. Let me write it out in a little bit different way. If segment BC is congruent to segment AB, and segment AB is congruent to segment EF, then transitive property, what can we come up with? See the link here? So we should be able to get segment BC congruent to segment EF, according to the transitive property. Now, how does that relate to what's on the smartboard? Well, I said, if you know line 3 and line 4, then you can get line 5 based on the transitive property. It's like that's the hypothesis and that's the conclusion. So see what kind of things are in the statement column, and what's in the reason is the name of the definition or the property or the given information. That's what a 2-column proof is. Now, out of the 3 types, eventually we'll probably use 2-column the most. But at the beginning, the other ones can help us organize things a bit. Questions about statements, reasons? Okay, let's look at another type. I think you'll have to flip to 2.7 now. This style is a flowchart proof. Flowchart proof. It's going to use ovals for the statements and arrows to show the flow of the ideas. So it's not just going to be 2-column as you're going down. It's going to be more graphic, I guess. Uses ovals for the statements and arrows to show the flow of the thoughts. The justification or the reason for each step will be right below the oval. So here's the example we're going to do. Go back. Okay. Your blanks filled in. Okay. All right, so here's the sample. We're given that RS is equal to UV and ST is equal to TU. And there's a picture to go with it to show you how we want the points organized. The tick marks were put on here to match the given. RS and UV have the same tick mark. ST and TU have the same tick marks. And out of that given information, we want to come up with proving that RT is congruent to TV. How will we know when those two are congruent? What's that definition? Congruent segments.
Common segment.
Congruent segments are what? When are two segments congruent? What was that definition? See how studying the Quizlet flashcards could help now? Congruent segments are segments that have the same length. So if I can get RT and TV having the same length, then I'll be able to say they're congruent. Okay. this is what a flowchart proof looks like. It's more graphic. It has like an oval, and right underneath it is the reason. Okay, and the arrows tell you what things connect the ideas. Okay, to think through this, start over here. Okay, the first oval has RS equals UV and ST equals TU, and it says that was given. Okay, drawing your example. So that's the given information to start us out. Now the arrow connects down saying, okay, that can lead us to this statement. Okay, how did we get this statement? Well, it says the reason, addition, property of equality. So we're adding things on each side. So let's get it written down and then I'll point you to where that is coming from. You have to understand the reason to make sense out of the proof. Right, Tina, you're writing it down? I think I'll pause, see if you can get all of it written down, and then we'll go back and make sense out of it, okay? Okay, let's try and make sense out of what's there. Okay, what kind of things are in the ovals? Are they statements or reasons? The statements are in the oval. The reason is right below it. So this information was from being given. Okay? This statement comes from the addition property of equality. And it said that by the arrow, this leads to that addition property. Now, how did they do the adding? Okay. RS plus ST. What's on the left was added, and what's on the right was added. So we added on the left and on the right, addition property of equality. Okay, now notice it doesn't have an arrow going down. So this new place that we go up here is, you don't need this to come up with this one. So it's a new idea by itself. So a new idea, segment addition postulate. Okay, we did that the other day. Again, RS's length plus ST is going to give us RT. And TU's length plus UV's length will be TV. Now, why did we do that? That idea and what's over here, notice together, substitution will create this. Now, how did they substitute? How did they put this and this together? Well, what I'm seeing is RS plus ST is the same as RT. So take this side out and put RT there instead. And on the right-hand side, TU plus UV, it says is the same as TV. So take out those two and put TV on that side. Substitute. Then the arrow says from there, we get to this last idea. By the definition of congruent segments, we have two lengths that are equal. If those lengths are equal, then the segments involved are called congruent. Statement, reason. Arrows tell you where the idea is hooked together. That's what I want you to take a look at on the flowchart proof. Question on following the arrows and the ideas? Okay, let's take a look at what the last type is. The last type is a paragraph proof. A paragraph proof proof is gonna look more like just a written out bunch of sentences in a paragraph. It's a style of proof that presents the statements of the proof and their matching reasons as sentences in a paragraph. And this style might not look as formal as like the 2-column numbered and everything, but it has all the same facts. It's not as graphic as the flowchart, but it has all the same facts in it. So a paragraph proof, here's the one we'll do for an example. We're going to be given that picture, and measure of angle 1 plus measure of angle 2 is going to equal measure of angle 4. That's what they said is special about this problem. You're trying to prove that the measure of angle 3 plus 1 plus 2, all three of those add to be 180. Here's how they get it done. Here's our paragraph. It looks like 4 sentences in a paragraph. Okay, so as you're writing those sentences, let's pick out what's the statement, what's the reason. Okay, this first sentence says, it is given that measure of angle 1 plus measure of angle 2 equals measure of angle 4. What part of that sentence is the reason? What's the reason? Like if you were doing 2-column, what would be on the right-hand side?
Measure of angle 1 plus
What
measure
are-
of angle 2.
What are reasons? Reasons could be that it's given a certain property, a certain theorem, a certain definition, a certain postulate. So in that first sentence, see the word given? That's the reason. Okay? So it is given, that's the reason. The statement is angle 1 plus 2 equals 4. And where did that come from? Right up here. It was given. Okay, the next sentence says angle 3 and angle 4 are supplementary using the linear pair theorem. The reason, linear pair theorem. Now you've got to know what that theorem is. That theorem said if there's a linear pair of angles, then they are supplementary. So these two, 3 and 4, must be a linear pair. How can I tell that? Look at the picture. 3 and 4, linear pair. They're adjacent and make the straight line. So there's your statement and reason. So measure of angle 3 plus measure of angle 4 equals 180 degrees according to the definition of supplementary angles. What is that definition? Supplementary angles are
2 angles that add up to 180.
2 angles that add up to 180. So since we said 3 and 4 are supplementary, we can make this addition problem that shows that they add to be 180. That's the statement. And then at the end it says by the substitution property, so that's your reason, substitution property, measure of angle 3 plus measure of angle 1 plus measure of angle 2 equals 180. Okay, how do we get that substitution? You see this right here, 3 plus 4 equals 180? What's measure of angle 3 equal to in this problem? I don't see a 90 anywhere. What's it say measure of angle 4 is equal to? I'm looking back in the sentences. Measure of angle 4 equals 1 plus 2? So if I would take what I'm highlighting here, take out angle 4 but put 1 plus 2 in its place, wouldn't that then read measure of angle 3 plus measure of angle 1 plus 2 equals 180? Just like it says we would get when we substitute. So we're taking out measure of angle 4 and putting those other 2 angles in its place that it says it's equal to. That's what's happening with that substitution. What I need to have you tell me is, when you read the sentences, are you seeing there's a reason, there's a like theorem or definition or given stated, and then there's a statement also? So each sentence has a statement and a reason in it. You see that? Thumbs up or down? Some are seeing it, some not too good. Just read carefully, and knowing your 5 types of reasons, it is given, given, that's a reason, okay, that, here's the statement. This isn't naming any theorem, so that's the statement using, okay, here's the reason, that theorem. So look for the name of the postulate or theorem or property as you go through. Now what I want to be able to do is want you to be able to do, is take one style and turn it into the other style. So there's 2 column, there's flowchart, and there's paragraph. Okay, let's take that one that we were just looking at because we had so many puzzled faces. Let's put that in a 2 column and then also in a flowchart. We'll do those fairly quickly so that we can compare the 3 types. Okay, so I'll flip it back to that same 2 column or paragraph proof. Let's put it in a 2 column. 2 column, what goes on the left? What's it called? Statements. Statements and reasons. Okay. Question?
No.
You know how to start?
Yeah.
All right, first line.
M equal 1 plus N equal 2 equals N equal 2.
What's the M mean? Measure. Okay, so that's her first statement. Notice I put a 1. First statement, what's the first reason? Given. In a 2 column, we number everything so we know what matches. Okay, first sentence done. Read the second sentence. What's the statement? What's the reason? Okay, angle 3 and angle 4 are supplementary. Abbreviate. Reason? Linear pair theorem. Okay. Third statement, third reason. Jaden, what comes next? And what's the reason? Abbreviated a little bit there. Fourth one? Riley? We're on the last sentence. As you read the last sentence, can you pick out which part's the statement and which is the reason?
Angle 3, angle 1.
Which side? Which side should I write on? Over here?
Statements.
Okay. Measure of angle 3.
The plus measure of angle 1 plus measure of angle 2 equals 180.
And the reason?
Substitution property.
I probably should put the whole title. Says substitution property of equality. Okay, so we went from the paragraph and turned it into a 2 column. Okay, thumbs up or down? Follow that? Okay, good. Let's take that same one and put it in flowchart. What's flowchart look like? The ovals and the reasons and the arrows connecting. Okay, so oval. What's our first oval gonna be? What goes in the oval? Is that the statement or the reason? Statement. So first statement, measure of angle 1 plus measure of angle 2 equals measure of angle 4. Reason? Given. Okay. Second statement, now what I need to decide on the flowchart proof is, do I need to have this connect to the second one or not? Do I need this line in order to say that 3 and 4 are supplementary? No, it really doesn't connect. So line 2 is a new idea by itself. So not connected yet. A new idea is that angle 3 and angle 4 are supplementary. What's the support for that? Linear pair theorem. Okay, for line 3. Does 3 rely upon 1 or 2? Yes, which one? 2. Okay, so from this one, then we come up with measure of angle 3 plus measure of angle 4 equals 180 degrees. Definition of supplementary angles. Line 4. Substitution property of equality. It's not going to use 3 and 4 being supplementary. That doesn't have anything as far as an equals equation in it. Do I need this one? Do I need that one? Do I need them both? Everybody had their iPads down. Okay, I thought I had flipped them all down. Okay, number 4, what can we come up with on that one?